Sets on it, hangs from it is a quote from Allen Beaumont, a certified professional member in Orlando and the master of ceremonies of our American Residential Design Awards dinner. He's referring to a structural member in a building. Whatever it is, a wall, a beam, a header, it's designed to support something that either sets on it or hangs from it. Sometimes both. As building designers, it's our job to think about those things. And Allen and I discuss it in a bundle of online educational courses titled Defining Your Architectural Style, and you can get to them through our education page. The total load that either sits on or hangs from is made up of two parts, live load and dead load. And any of you who are parents know what dead weight feels like. That is, if you've ever picked up a kid who fell asleep watching TV and toted them to bed. The dead load is a little different. In a building, it's fixed and not something that you can carry, at least once it's been installed. On the other hand, the live load is the stuff that, if you could, pick up the house and turn it over and would all dump out onto the ground. Wouldn't that be handy for snow removal? Now here's how the International Residential Code defines them. Dead loads are the weight of the materials of construction incorporated into the building, including but not limited to walls, floors, roofs, ceilings, stairways, built-in partitions, finishes, cladding, and other similarly incorporated architectural and structural items, and fixed service equipment. Live loads are those produced by the use of the occupancy of the building or other structure and do not include construction or environmental loads such as wind, snow, rain, earthquake, flood, or dead loads. Why is this important? Because the occupancy of a building determines the types of live loads to include in the calculations when designing the structural elements. Here's Table R301.5, also found in the IRC. It requires that floor assemblies in a bedroom be designed to carry at least 30 pounds per square foot of live load. All other floor areas, like great rooms, must be 40 pounds per square foot. And there's no requirements for concentrated loads. Think about this though. According to a study done by Slack, 2/3 of employees either work from home exclusively or have a hybrid workspace. This office studio that I'm working from is a bedroom in the second floor of my house. So I looked up the size and weight of a file cabinet. A 4-drawer metal cabinet is 14 by 18 and weighs 35.5 pounds empty. That's only 20.2 pounds per square foot. But how much does it weigh when it's full? A drawer holds at least 6 reams of paper. At 5 pounds each, that's 30 pounds per drawer, or 120 pounds plus the cabinet's weight. Now we're talking almost 90 pounds per square foot. According to the International Building Code, floors of an office space are designed to support 50 pounds per square foot and 2,000 pound concentrated loads. Here's another example. If you were designing an assembly hall, the floor loads would be designed to carry 100 pounds per square foot of live load. In a house, having cocktails before moving to the deck or backyard for dinner, how many people might fit into a 20 by 30 kitchen and great room area? Should we consider these scenarios if clients express that they work from home and like to entertain? Now, before you or they go to the expense of involving a structural engineer, are you able to do some basic engineering calculations using uniform loads to see if there might be a concern? Now, would it be helpful to be able to at least set expectations for your clients by telling them how much their floors or ceilings might deflect under these conditions? Deflection is always present. It's just a matter of whether you can see it or not. Now, we have a webinar for that, and I've arranged for you to have access to scheduled replays anytime you want for the next 3 days. The 1-hour training covers the procedures and formulas for sizing structural members like floor joists, ceiling joists, beams, rafters, and more. Renato Carati, a professional engineer in Florida, and the instructor will prepare you to confirm that your home design meets a modern family's needs. Go to aibd.org/structural webinar anytime between noon today and noon on Thursday to brush up on your math skills for sizing simple beams. The cost is only $21 for everyone for the next 72 hours. After Thursday, the price goes up. If it's your first time learning these formulas, you may want to rinse and repeat a few times. The formula takes some practices, and then you'll want to go back and refer to the PDF worksheets. Just for that, you'll have access to the webinar for a year, but you have to register before noon on Thursday. So go, buy your ticket right now before you forget. Thanks for watching this entire video and have a formative week.